When it comes to embedding models and providers, there's so many to choose from, and sometimes it's very challenging to make that decision. It's tough to decide which embedding model to use, which provider to use to host this model, whether you need to locally host this model or use an external API. In this video, I want to go over some of the trade-offs and the decisions that you might need to make when you're working with embedding models. So there's two main types of embedding models: open source embedding models and closed source embedding models. Open source embedding models have a major advantage that you could work with them locally. This means that you could, for free, download the model and process all of your data locally. And this is going to be much cheaper if you have a lot of data than working with an external model provider. Another thing to note is that paid closed source models are typically pretty cheap until you hit scale, and then those costs really add up. So with open source models, you have the advantage of not only do you have the ability to process all this original data for free, but you're going to save a lot of time doing it, because sometimes it's difficult working with external batch APIs, and you might just have an easier time doing it locally. But they do have their disadvantages. One big disadvantage is that your particular model may not be supported by providers for cloud inference, or in general, it's typically more challenging to deploy these embedding models. So this is just something you have to keep in mind. But the main times you should use an open source embedding model is when you have a lot of local data that you want to process and you don't want to share your data with the external embedding API. Because for closed source models, they host their own infrastructure for doing inference, but you do have to send them your data. Another advantage of open source embedding models is that you have complete control over your search pipeline. If you want to, you can move off external provider and host all this inference infrastructure locally. And this means that if you have a problem, for example, inference is too slow on a closed source provider. Often for closed source providers, it's 200, 300 plus milliseconds. That might be too slow for your use case. So what you could do is you could host it yourself and have that sweet 10 millisecond inference if you want to on a custom VPS, for example. Closed source embedding models have their own advantages. For one, they have reasonably fast inference, because what they do is they deploy their own infrastructure, and that means that they could make optimizations that might be challenging for someone to do if they're doing inference themselves on a local server. But typically they use batching, so it's not as fast as if you do all the optimizations yourself. So that's just something you have to keep in mind. There's often additional benefits. For example, OpenAI has a batch API, which means if you have a lot of data, that might be somewhat easier to work with. Although for closed source models, I feel like if you have a lot of data, it's easier to embed that locally. And there's closed source models that perform better for certain use cases. For example, Cohere has an excellent multilingual model. And there's also models that are closed source that are on top of the MTB leaderboard. We're going to get into that in a bit. But for example, Voyage AI has instruction embeddings that may perform better for certain use cases. And some of these closed source embedding providers have very robust free trials, which means that for Voyage AI, for example, you could get 50 million tokens embedded for free, which is pretty reasonable. These closed source embedding models are useful when you don't have a lot of data or are willing to pay to embed your data. You don't want to host custom infrastructure, and maybe this particular model that is closed source has better performance for your particular use case. If you were moving quickly, I recommend just using a closed source model and using an embedding provider like OpenAI or Cohere, and you're going to have a much better time developing in practice. The Massive Text Embedding Benchmark, or MTB leaderboard, is a great tool to figure out what model is the best for a particular task. Let's say your task was classification or clustering. You could use this tool to figure out which model is best. There's also an overall leaderboard which finds which model is the best overall. As of this video, that's the Voyage Large to Instruct model. This is where I go when I want to figure out which embedding model is the best for my particular task. Now, this leaderboard has both closed source and open source models, but it's a really good place to get started. One model that I really want to talk about is the Cohere Multilingual Embedding Model. It supports over 100 languages. It has best-in-class performance for multilingual search. It's closed source, but Cohere has excellent pricing, so in production, this might not be too much of an issue. Its main use cases are multilingual semantic search. If you're dealing with a lot of multilingual data, this model is going to perform much better than something that is based mostly on English data. For example, if you're aggregating customer feedback, which is often in many different languages, this is going to be really useful to search for similar comments and to aggregate and classify and cluster them in some way. It could also be used for cross-lingual zero-shot content moderation, which means it can detect harmful content in over 100 languages. The most popular choice for embeddings is OpenAI embeddings, and there are a lot of reasons for this. One is that it has a really simple API with excellent documentation and lots of examples. It has excellent performance, not as good as hosting your own solution, but it's been heavily optimized. And it's relatively cheap until a certain scale is reached. One thing that needs to be understood about performance is that performance when you're embedding your data set doesn't really matter. You could have really slow performance. You could use something like a batch API, which OpenAI offers, right? But if you're really looking at inference performance, which means your user just has a query, then you have a very different performance requirement. So OpenAI is closed source and you can't really run the model yourself. But the dimensions can be reduced without the loss of too much performance, which means faster embedding generation and lower search latency in your vector database. One thing about the OpenAI embeddings API is that OpenAI docs recommend using cosine similarity for most use cases, and that's because OpenAI embeddings are normalized to length 1, which means that cosine similarity is going to give you the exact same results as Euclidean distance. And these models have pretty good performance. The small models do pretty well. They're reasonably cheap. They have a maximum context size of 8,000 tokens. And their MTB evaluations show great performance. So OpenAI is a very strong option if you're looking for an embedding inference provider. Another great option is Voyage AI embeddings. Voyage AI recently came out with a Voyage Large 2 Instruct model, which immediately topped the MTB leaderboard. This model is instruction tuned, which means that you could add additional context to your query and documents, which may improve performance. For example, you could add context to the documents saying that they are job candidates to be searched, and this might make the model perform better if you're trying to compare queries to job candidates. But you don't have to add additional context. This model works very well out of the box with no additional instructions. It has 1,024 dimensions. Now, if we compare that to the other models at the top of the MTB leaderboard, it's much lower. Most of these models have thousands more dimensions, which means you get better performance at lower latencies. Another advantage with Voyage AI is that it has an excellent free tier, 50 million tokens embedded for free. I haven't hit this rate limit yet, and I've been doing my best to hit it. Now, if you don't have a credit card, you could still use the Voyage AI embedding API for free, but the rate limits are going to hit you extremely quickly. Another advantage is very fast inference because it's hosted. But again, it's not as fast as you may want it to be for certain use cases, so you are locked in with this vendor. A great library for working with embedding models is sentence transformers. Sentence transformers is a Python framework for sentence, text, and image embeddings. It works with most embedding models on Hugging Face, which is an open source ML platform. And it's typically pretty slow, but robust. So it supports all embedding models on Hugging Face, but downloading this library and doing inference is going to be pretty slow in practice. Another option is FastEmbed. FastEmbed is a really fast library for generating embeddings. And it's a Python library, it's very lightweight, and it's faster to install and do inference with than sentence transformers, but it has a limitation in that it's limited in the number of models it supports. But it does have GPU acceleration. So if you have a GPU and you want to generate embeddings for millions of documents, this library is going to save you a lot of time. And that's it. I really hope this video was helpful. And in the next video, we'll be going over retrieval augmented generation.